Welcome to Grouping and Combining Data for Finance 372. Real data never comes in a single CSV file that has all the columns you need to do your analysis. Instead, you'll need to combine multiple data sources together that contain different columns, span different time periods, and identify investments differently. A big part of data analysis is bringing these different sources together so you can learn about the connections between them. The main tools for doing so in Python are called group by, concatenate, and merge. We'll start with the group by command, which allows you to group data together by category and summarize it however you choose. I've added some documentation and tutorials here at the top of this notebook, but let's jump right to some examples. We can start by loading the yield curve file we've looked at for a couple of these videos. So as you know, this data frame contains maturities, dates, and yields, and then we can add a price column using the standard formula and convert the date column to a date time column. All right, so now let's say we want to compute some statistics not for the entire data set, but just by each maturity. One way to do this would be to select all the data for a given maturity and then apply the statistics calculations to that. So for example, we could do something like this, which gives us the rows of this data frame that have maturity 1, the column of yield, and then we can get the average of that like this. Okay, but if you wanted to do this for all of the different maturities and you maybe wanted to get some more statistics besides the mean, becomes a little bit cumbersome, right? Because we don't even necessarily know up front which all those maturities are, and we have to then combine them into a new table afterwards manually. It gets to be cumbersome. Okay, group by allows us to do this more easily. To do this, we write df.groupby, and then we tell it how we want to group our observations. So we're going to make groups by maturity. All right, and then let's say we want to get the average for each of them. We can then do .mean. And now this command, when we run it, will tell us for each maturity the average yield and the average price. And there are lots of other things we can compute for each group besides the mean. We can also compute, you can give me a list of them here. There, we can compute the count, we can compute the first one, we can compute the first 3 or 4 using head. We can get the max, we can get the mean, the median, min, on and on and on. Let's get the min, or we can get the maximum, etc., etc., etc. As you can see, by default, the group by command uses all of the columns. Maybe we only want, though, to get the maximum price, let's say, across each column. To do that, we can specify our columns using df.groupby and then entering the column in square brackets here. So if we wanted only the price column and the maximum, we could do that. And you can see this is now the maximum price for each maturity. Now we can expand this to something a little more complicated where we can do multiple different aggregators at once. These functions we run at the end, max, min, mean, whatever, those are all aggregators because they aggregate each group into one statistic. So we can choose multiple aggregators and we can choose multiple columns even if we don't want to do all of the columns. So we still want to group by maturity, but now we want 2 different columns. Let's say we want the price and the yield columns. All right, so the way you do this is with double square brackets. It's a long story why you need to do that. We put both the columns in there. And now if you want multiple aggregators, the way you can do that is by using the .ag command, which is the general aggregator, and then passing into it the names of the 2 different aggregators you want to use. So let's say we want to do the mean and the standard deviation. Okay, now when we run that, you see you get this nicely organized resulting data frame that has, for the yields, we know the mean and the standard deviation of the yield. With the prices, we have the mean and standard deviation of the prices, and these are organized within each group of maturities. Now let's imagine we want to group by years instead of maturities. To do that, we need to first create a column that tells us the year, creating a new column called year, assigning the value of that column to be equal to the date, and then to get the datetime.year out of that. Okay, this is one of those things where if you wanted to convert a date time to a year, you could probably ask Professor Google how to do that. Now that we have a year column, we can group the data by year, and then we can ask for the same aggregators for the same columns that we had before. Now you can see for each year, we have the average yield to maturity, the standard deviation within that year of yield to maturity, the mean price, and the standard deviation within that year of the price. When you group by year like this, what you're doing is you're combining all the different maturities into one row. Maybe instead what you want to do is get a summary of what the 1-year yields to maturity were in 1941, the 2-year yields to maturity in 1941, et cetera, et cetera. So then what we want is to group by an interaction between year and maturity. So we want to group by year times maturity. The way we do that is by telling group by to group by multiple columns. So we can tell in here that we want to group by both year and maturity. And then we can copy the rest of this down here. And we're grouping by year and maturity. We're showing the columns of yield and price. And we're using the mean and standard deviation aggregators. So what we get is for each year and each maturity, the mean yield and the standard deviation within that year, the mean price and the standard deviation within that year. All right, lastly here, you'll notice that what's happening is that it's lumping together all these observations with the 1 year index and then making a sub-index for each of the maturities, 1, 2, 5, 7, 10, etc. When we start merging this with other data, this may not be very convenient. And so sometimes we'll want to do this again with a fresh index. The way you do that, you have the same, is you run the same command, but at the end you do reset index like so. So now what's happened is it's created a new index that's just 0 through 544. And now year and maturity are just ordinary columns in this data frame. Might make merging easier for us later. If you want to know more about all the different aggregators you can use, check out this group by tutorial here and the documentation here. Now let's think about a case where we have two separate data sources we want to combine together. Now if you notice, the yield curve data we've been working with ends in 2018. So let's say we want to update that to include new data from 2019. So I've included a yield curve 2019.csv file. If we read that into a new data frame called df19, change its date column into date time, and see what we're looking at here, you can see that we have in here the date, maturity, and then yield to maturity YTM for 2019. Now we want to concatenate the new data into our old data. Concatenate means take the old thing and just paste on the new thing at the end. So to do that, we're going to create a new data frame that we'll call df_all, and then we use pandas pd.concat, and we tell it the two data frames we want to concatenate. So that's df and df19. All right, let's see what that gives us. So as you can see, it's taken the original data, which has this year column because we added it, has the price column because we added it, but it also has yields, dates, and maturities. Now it's done a good job in adding the maturity and date here for the new data, the 2019 data. So it used the names of the columns, even though maturity and date were in different order as columns in DF 2019 versus DEF, it still was able to correctly append those on the bottom here. But what it wasn't able to figure out is this yield thing, because the original data frame had yield column labeled yield. The new DF19 had the yields column labeled YTM. Okay, so the easiest way to fix that is we need to rename our original column to be yield instead of YTM. Okay, and the command for doing that is df.rename, and then we tell it we want our columns to go from YTM to yield. Okay, so now if we load this way, we get a yield column, and we can concatenate that, and now we have everything in the maturity, date, and yield columns like we wanted. Okay, if we wanted to go back and add the price and the year, we could do that as well. So this is fairly typical, even when you're just trying to concatenate in new data or smush together two different data sources for the same thing, you'll often have to rename some of the columns to make sure that they match up. Now imagine that instead of combining two chunks of data that should go together vertically like this, we want to merge together new columns into the same data set. Okay, let's imagine here we're trying to study the relation between these yield curve data and GDP growth. Well, then we want to merge in GDP data where we have a new column in our data set that contains GDP growth, for example. All right, now GDP data comes from a different source than the yield curve data. So I've included this gdp.csv. We can look at what that looks like, and it's a very simple annual GDP growth data frame. All right, so now we want to merge this into our yield curve data. So the way we do these merges, we always need to make sure there's a column in each data frame that matches, so that we'll use that column as a key to say, okay, this row in this data frame should match up with this row in this data frame. Okay, in this case, we're going to use the year column. Okay, and let's just do the first merge where we take this data frame here and add in this GDP growth column. To do that, first we need to make sure this year column is available for the new data in 2019. To do that, we can use the same command we did before, but change this to df_all. So the way you merge in the GDP data is by using this df.merge command. You need to tell it what new data you're bringing in. So in this case, we want the df GDP data to come in. And then you need to tell it which columns you're going to be using as keys to merge them together. So how will I know which row from the first data frame to match with which row from the second data frame? Well, in this case, we'll use on equals year. So we want to get data from the GDP growth data frame that has the same year as the year of our original yield curve data frame. Okay, then the third thing we need to tell it is how to do this merge. So there's going to be 3 different choices we'll consider. And the first one is going to be called a left merge. The idea with the left merge is we take the original data frame, which has the yield curves in it, the DF all. We're going to keep it exactly as is. We'll keep those exact rows as they were before. So we had 6,589 rows before. After the merge, we're also going to have these exact 6,589 rows. The only difference is we're going to add a column for GDP growth, and we'll fill it in whenever we can. Okay, notice in this case that the GDP growth data doesn't start until 1950, whereas the yield curve data starts in 1941. And so we're going to be missing about 10 years of GDP growth data when we merge it in here. What we're going to do is we'll keep those observations and we'll just write into the data frame, okay, those are missing GDP growth data. And let's have a look at what that looks like. So as I said, we have now this GDP growth column for every observation. Sometimes it's missing. In the 1940s, it's missing. Later on, it matches. We'll have duplicates here where we have many different observations for 2019. All of them will get the same GDP growth column. Okay, so these left merges are ideal if you want your original data frame to be left alone in terms of its rows. All right, but what if you want to get only observations where you have both the GDP data and the yield curve data? The way to do this is using an inner merge. So this uses the same command, dfall.merge, but now we say that how is equal to inner. So we run this, you can see we have fewer observations, only 5,880, but they all have the GDP growth data and the yield curve data in them. Okay, so an inner merge is ideal when you want to bring together 2 data frames and keep only the observations that are in both data frames originally. The last choice we can think about here is a right merge, which is the opposite of a left merge, where now what we're doing is we're keeping every row from the GDP data frame, matching them to the original yield curve data frame when we can. So when we run this command, you see we now have this row at the end here where we have 2020 data that's in the GDP growth, but we can't match it to any of the stuff in the yield curve data. We still throw out the 1940s because we cannot match this GDP growth data with anything there. So a right merge guarantees that you get everything that was in the right data frame, in this case the DF GDP, and we'll try to match the left data frame when it can, but if it can't, it just gives up and deletes that row. But when it can't, it just gives up and then enters missing values for the yield curve data. Now let's bring together the group by idea and the merging idea. Now let's say we want to make a data frame that has only one observation per maturity year pair. So we're going to take all the yield curve information and say, what is the end of year yield for each maturity? And then we're going to match that with the GDP growth data. All right, so we're going to do this with 2 steps. We're going to first group the data. We'll get this yield curve end of year data set by using the group by, and we're going to group by year and maturity. So we're going to collapse this data frame into a new one where each row represents an entire year for an individual maturity. And now we're just going to get the last observation within each year. And we also want to reset the index because that'll make the merging easier. As you can see now, we only have 545 rows because each maturity year, there's only one observation now. These dates, yields, and prices are just the end of year values for each because we use this last aggregator. So now we can do our 3 different merge types again now to get a grouped and merged data frame that is much more manageable and maybe closer to our final analysis. So here's our left merge. This again keeps all 545 rows as GDP growth when it can. This is an inner merge. Note that I'm saving some notation here because inner is actually the default. So if you don't say how, it will assume inner. I'm also omitting the on equals year because Pandas was smart enough to look and see the names of your columns and guess what you're merging on. Okay, so to be careful, you always should probably type on equals year. I just wanted to show you that there is a default and sometimes it will work. So if we run this, now we get 483 rows where every single row has both the GDP growth and the yields and prices. Okay, of course, you can flip this around. Instead of doing dfyc.merge dfgdp, we can do dfgdp.merge dfyc. And since the default is an inner merges, doesn't matter whether you merge A into B or B into A, you get the same exact thing. And the only difference here is just the order in which the columns are presented. And finally, we can again do left merges and right merges on this grouped data frame with the GDP data and get slightly different results. And so have a look at all the different examples in this notebook and try to really understand how you would correctly use them to solve different problems.